Good morning, everyone.
Good morning. A few housekeeping items. Go to the Zoom chat. We're going to have a Q&A session a little later. So go ahead and start submitting questions at your leisure. But I'm Nick Guida from Tamarack Aerospace Group. I'm an aerospace engineer, the founder of Tamarack, the CEO, and also the inventor of the active winglet. Jacob, our president, we're here to talk about a very exciting business expansion that supports the demand for our product and the growth that we're seeing. We're very excited about it. We have this game-changing technology that we're ready to take out to the larger market. We have a patented technology that really saves a ton of fuel, reduces carbon emissions. We've been around for 10 years now. We had our 10-year anniversary earlier this year. We're excited about that. Have over 100 aircraft in the fleet, flying and saving fuel and doing amazing things in our customers' jets. And we really haven't been hit with COVID too bad. It hasn't affected our business, fortunately. And there's never been a better time for this type of product, for what we have, what we offer. But the big news is, on the heels of a very successful EU launch of our transformation center in Oxford, England, a couple of months ago, we're happy to announce, very proud to announce, East Coast Transformation Center in Aiken, South Carolina. We teamed up with Mike Laver and his gang. They've been around for decades, aircraft experts. It's a great location. They know what they're doing, and they're really focused on customer experience, just like we are. And we were looking for factory level installations, where, for instance, we did 50 here in 2018 because we got it down to a science. And we're looking for that customer service that allowed for a customer to come in and as little as 7 days, get their plane in and out to minimize downtime. So we're excited about that. Similarly, in our Oxford Center in the EU, citation experts, we team with them and partnered with them. We have a few people, Tamarack people working there, doing these installs. We've already gotten 2 in Europe. One is actually in process, and then Aiken is starting tomorrow. So we're very excited about that. So let's talk about the overall footprint of Tamarack. We have our headquarters here in Sandpoint, Idaho, beautiful North Idaho. Come and see us and go skiing. We have, over the years, we've grown. We have 3 hangars now, pretty large hangars, based on R&D and installations and engineering. We have this beautiful studio and an office building. So we are expanding our footprint here, not just geographically, but also floor space too. So on top of the Aiken Service Center, which will provide top-notch quality installations, we have our transformation center here and the one in the UK. We also have almost 20 service centers around the world that can support maintenance on a Tamarack aircraft, Tamarack Atlas equipped aircraft, if the need arises. But it's not only geography and floor space, it's also our team.
That's right. We're really proud. 2020 has been a rough year for everybody, and it's been rough for everybody. But we started this year with 20 employees, and we're going to close the year with over 30 employees. And like Nick was talking about, that's not only for our transformation centers, and we now have the 3 transformation centers. We're seeing plenty of demand for the winglets even through the pandemic. But we're also expanding our product line. So we've hired sales staff to support our sales. We've hired installation and production staff to support our sales and installations. But we've also hired quite a few engineers, and we are hiring engineers. We have open positions right now for our R&D efforts. We're not ready to make any announcements, but we are expanding our product line beyond the CJs. And so we're adding staff for that expansion into other platforms. And not only our platform. So we have this core base, this core team of excellent engineers. We were the first to certify and develop active load alleviation in Part 23. And so we have a really good core of engineers. And so we're adding to that core of engineers and using that with other companies, partnering with other companies who recognize that Tamarack understands innovation and doing new things. And they've come to us and asked, hey, can you help us with certification on these new and innovative products? And we're happy to do that. We enjoy that. So we're adding to the team to support that as well. And like I said, we've grown from 20 to over 30 employees as we close out 2020. And we're really excited about the innovation that we get to be a part of. And a big piece of that innovation is doing new things, but also looking at the sustainability aspect of what's going on in the industry. You know, the sustainability effort started to really get some effort going before the pandemic, and that was sort of set aside due to the pandemic. But as we now emerge from the pandemic, hopefully sooner rather than later, that's going to have a lot more emphasis. And so we're really happy to have, you know, a product that's really keyed into sustainability, but be partnering with other companies who are doing the same.
Yeah, and when it comes to sustainability and understanding what our product offers, we'll get into the details a little later after the Q&A, but we'll talk about in general terms what we mean, what sustainability means to us. So overall, if you think of what Gamma, the 4 target areas in aviation that we can really focus on to promote sustainability and reduce environmental impact of air travel, we have alternate fuels, sustainable alternate fuels. Operation side, that's kind of where we fit in. Technology is definitely where we fit in, and the infrastructure where we don't fit in necessarily. But let's talk about operational. For instance, this plane behind us, the CJ, gets to higher altitudes quicker, more direct routing in Europe, max fuel weight increases, those types of things. So, and we'll get on that a little bit later, but I want to talk about in the operational and the technology phase, or aspects of those key elements of sustainability, we're really focused on. So what we have here is, let's think about an aircraft flying. There's four forces acting on an airplane: thrust, drag, lift, and weight. So take one at a time. So thrust, the engine manufacturers are trying to squeeze every ounce of efficiency out of every ounce of fossil fuel or electrons for motors. So that whole industry is focused on just getting the best, and they're doing a great job. Over the years, they've come up with all these cool innovations that make the aircraft quieter and the propulsion system better. With respect to weight, which is one of the main detractors of an airplane, airframers are coming with new materials, new processes, new systems, lighter avionics, all these types of things, lighter gear that just impact the overall weight, because weight is a major contributor to creating the negative, it's hard for engineers to design around weight, but they're doing a great job. But a really big part of sustainability and environmental impact reduction is increasing the aerodynamic efficiency, lift over drag. And that's exactly where we fit in. So aspect ratio is key to lift over drag increasing. That's why you'll see Boeing and NASA have teamed up, and they have a strut braced, they're theorizing a strut braced airliner, very high aspect ratio wing, like a U2 or a glider, because really that's where the induced drag is reduced the most. And so that's happening right now. People have been talking about it for years, but we have a product. We have 100 of these flying right now. So we're really excited about bringing this back into the forefront focus of sustainability. This plane behind us, the CJ, it's a 20-year-old plane. It has like 4,000 hours on it. And these planes have 20 to 30 hour lives, 30,000 hour lives. So we're upcycling. Think about the core of sustainability is upcycling. We're taking an older plane and letting this 3-hour plane at max continuous on the same tank of gas go 4 hours now. So a flat wing version, 3 hours, you put some winglets on it, because we have this extension and a load alleviation system and a winglet. All these other things add up together to have huge increases in the efficiency of the aircraft. So that's the L over D portion. So we're excited about these elements that we can bring to the forefront. If you look at all the percentages of where we can increase efficiency, L over D is kind of number one thing. So we're excited about having something here right now. Instead of 10 years down the road, it's here right now. We're flying it. It's pretty exciting.
Yeah, and our product, right now we're doing the Citation jets, but our company wasn't founded to do Citation jets only. We consider ourselves a technology company. We have over 30 patents related to what Nick was talking about with efficiency and load alleviation and other wingtip treatments to increase efficiency, allow the higher aspect ratio without the structural penalties that are normally associated with that. And so we think about our business in kind of three areas: business jets, which we're doing, and there will be more. There's military opportunities into the defense space, and also commercial space. So we're doing business jets now. There are other business jets that could use our technology to climb faster, cruise higher, and burn less fuel. But also in the military space, if you look at airplanes that are being used in that space, you've got the C-130, you've got the Dash 8, you've got King Airs, a handful of aircraft. What we can provide to those aircraft is big for mission readiness, endurance increase, range increase, things that are really important to operations in theater, that they really can't get any other way. So we can take an airplane that would have been grounded because of high hot conditions and allow it to fly for hours when it would have been stuck on the ground. So that's a massive improvement for the defense community. We're excited about opportunities there. And then there's the commercial space. You know, if you look at what API and Boeing have done with the blended winglets over the years, it's really great. They're claiming over 12 billion gallons of fuel saved with the blended winglet, which is tremendous, but we can do even better. You know, we're adding wing and we're adding the winglet, which makes a really big impact. And we can do, you know, they're getting about 4 or 5%. We can do 12 to 15%, which would be significant. So we're excited about those kind of opportunities, and excited about the opportunities for the industry going forward.
Yeah, and so part of that is us being involved in and going to Congress and talking about this, and Congress realizing, and certain committees, and realizing that this isn't just a product, it's a concept that could be taken to other platforms, and it's pretty exciting. So we're involved in NBAA discussions. Like tomorrow we have on the sustainability panel, Rolls-Royce and Duncan, and we are on IKO panels, and all those type of discussions are now coming to the forefront because of the perception and the political side of what we're dealing with, and having the environmental impact. Just like in Europe right now, some of the stimulus packages from the European governments require attention to this and meeting the ICAO goals. So we're in the forefront of that, and we're trying to make an impact. But remember, because like Jacob said, we can do, you know, 12 to 18% above a 737 with a winglet on it right now, a triple, quadruple the benefit. That's hard to swallow for most people until people fly the jet and they realize I can go an hour further with my same fuel tank, same amount of fuel. It's hard. It's such a step change in performance that it's almost too good to be true. And that's a challenge of having this amazing technology. You know, Joe Clark, no one everybody thought he was crazy back 25 years ago. And how many planes did Joe and his team, how many planes did they modify? So this is really the next generation. The winglet's been around for over 120 years. The first patent was 1897, and nothing really amazing has happened since then. Split winglets are around since, well, the Connies, right? And I have pictures of it in 1910 of aircraft with winglets on it. So what makes us different is we have this extension and the winglet and the load alleviating device called a Tamarack active camber surface. You'll see, I think, the picture showing that right now. So overall, I want to thank you. We're going to take some Q&A right now. And don't forget the sustainability panel tomorrow. So, and visit our website and our virtual booth too. We have a lot of great presentations and things to check out. So I'm going to open it up to Q&A. And yeah, we're going to open it up.
You can go ahead and type questions in. We've got a few questions that were sent in earlier. So we'll start there, but feel free to send in questions through the Zoom chat window. The first question we have is, how many employees will we have at each transformation center? To do a transformation, we have, like Nick was saying, we have it down to a science. So when an airplane pulls in, we can just get right to work. We have workstations all set up. So to do those, typically it's two structures, people, one on each wingtip, and then an electrical person, and then somebody to paint. So we're looking at about 4 people on the installation work itself. And then of course the quality side and painting is a couple more. So like for example, in Aiken, we have that kind of a team set up, but also our East Coast regional sales manager is stationed there. So so that's about the size of team that we have to do those installations in under 10 days. So I mean, we can do them quite a bit faster here in Sandpoint.
Yeah, I mean, the goal is to get all of our transformation centers to be able to do at least 3 a month. In terms of just quantity and quality. But we realized, so in 2018, we did 50 of these installs here, one a week. And that was a big seller for our customers. They would fly all the way across the country because they wanted it in and out. And not be, they had their planes to fly and have fun and business. So it was important. So we wanted to duplicate that in these other transformation centers. Sorry, I'll talk to you.
All right. Another question here. Where else will you expand your operations? Really, it's where the demand is. We chose Europe for our transformation center there in Oxford because we saw demand in Europe and also East Coast. Even though, of course, they're jets, people can just fly here to Idaho. But there is demand on the East Coast that we're seeing, so we chose the East Coast there. So it'll really just be based on demand and how we take it that way.
And the East Coast is a great place too because of the military things that are coming online. It's closer to the epicenter of military.
All right, we have another question. A traditional winglet adds the equivalent of 2/3 of its span to the wingspan. Has Tamarack been able to do better than this?
That's a great question. So we have a sophisticated question. So yes, actually a wing extension is more efficient than a winglet. A vertical surface does provide aspect ratio increase, but not as good as just an extension. So typically, like you can add, 10% of the aspect ratio increase with a passive winglet. We have an effective increase of 30%. So we have a geometric extension of about 5 feet on the CJ behind me, 5 feet. I'll show you. So this is the extension portion that we add. So it's about 2.5 feet per side. Then we have the winglet. So we have about a 15% geometric extension and a aspect ratio increase. And then we have another about 10 to 15% with the vertical. So yeah, we have a 30% effective aspect ratio increase. So overall, that's really where this huge benefit's coming in the step change. The added wing actually allows you to climb faster to higher altitudes. So your initial climb altitude is 3,000, 4,000, 5,000 feet higher than it was before, even in hot conditions. I sound like a commercial. Next question.
Let's see. You mentioned military and commercial aircraft interests. Who have you been talking with, and when will you be making further announcements? So, we're not at liberty to talk about that quite yet, but we do expect to be making announcements early next year on what our next projects will be. Like I said, we'll be working on those developments, doing the engineering work and the certification work, getting some of that moving, and then we'll be ready to make some announcements. We've got another question. Is the Challenger 600 series on your radar for winglets?
All airplanes are on our radar. Jacob hates when I say that. But yeah, so the Challenger is a wonderful platform. We've been talking about the Challenger for, I don't know, all of 6 years now. We know we have really good data, really good analysis to show that we can make an incredible increase in the performance. And in that case, it's initial climb altitude. We know we can take the jet. If you are familiar with the Challenger, the rule is 36-36. It's a 48,000 pound airplane, but until you're 36,000 pounds, don't expect to go over 36,000 feet. So just remember, with this type of engine, this type of airframe, every 1,000-foot increase in your initial climb altitude is about 3.2% increase in specific range. So think about going up from 36 to 41. That's 15%, 16, 17% range, a specific range increase right there. So yes, that is on our radar. We've had over the years a few starts and stops on that one, but we're excited about someday doing that one because all the analysis shows
it's going to be a big win for that platform.
I mean, and talking about the upcycling, right? The core of sustainability is upcycling. We're taking an older, wonderful plane. If you ever flown one, they're great planes to be in, and the cabin, everything's beautiful about them, but they just need a little more range. Well, that's where we come in.
Yeah, exactly. All right, there's no more questions. I think we wanted to spend just a few minutes just giving an overview of the technology in case you aren't familiar. We have this model. Nick, you want to move it maybe into the middle of the screen here and give an overview of what we're doing with active winglets?
Okay, so this is not a real life model. This is a scale model. and this represents the approximate proportions of the Citation jet 525s all the way up to the CJ3s. There's about 2,000 aircraft in this market. So the system consists of a extension. So this is about 2.5 feet each side, as you can imagine, unsymmetrical. Wingspan's not ideal. So it's about 2.5 feet per side. Then we have about a 3-foot winglet. So the original wing ends here, just like on almost all of our installations or all of our development R&D has a pretty healthy extension. For that same reason, the gentleman asked, or whomever asked, we want that we want the aspect ratio increase.
Right.
So aspect ratio, a higher aspect ratio increases the L over D, which decreases the induced drag. So when you're at high altitudes, flying along, cruising, or taking off when you're heavy, the form drag and the parasitic drag, well, the form drag and the induced drag are about equal. So if we can reduce the induced drag by about 30%, then overall it's about 15% savings on that particular flight segment. But the downside of adding a winglet to any plane, an existing airplane, is that you end up adding weight. So in my previous life, I was a consultant engineer, and I was doing modifications and putting winglets, passive winglets, 120-year-old winglets on King Airs and Hawkers and Falcons and things like that. And I would help as an engineer, help put metal in the plane to reinforce it to get the fatigue life back to where it was, or maybe take a hit on fatigue life. 737 adds almost 500 pounds of additional metal to the wing in order to withstand the winglet, because just imagine a longer wing has a higher aspect ratio wing has more bending moment than a traditional wing or a one without a winglet. So that's what's happening. You put this great aerodynamic benefit of a winglet on a wing, and you end up bending the wing more and sacrificing that efficiency by putting weight. The 767, it's almost 2,000 pounds of additional structure to withstand the load of the winglet. So this is where the low alleviation device comes in. So during these very short duration and very unlikely high G events, gusts and maneuvers, this device will either pop up or pop down, aerodynamically disconnect the winglet for a brief fraction of a second, or in a maneuver longer, as long as the maneuver is happening in that event. And the wing bending is actually lower than the original OEM flat wing bending. Mm-hmm. That's why we have max zero fuel weight increases. The CJ2 has an 800-pound max zero fuel weight increase. Yeah. And the added wingspan makes our climb rate, single engine climb performance incredible. So that's why we can offer tremendous high hot. That's why the military is so interested in the ISR side, and why we have that going now. So there's so many other benefits. There's ride smoothness. There's safer flights. Just think if you lost an engine coming out of Aspen, we had almost 1,000 additional pounds in high hot operations coming out of Telluride. It's a 9,026-foot airport, 1,000 pounds more if you do flap zero. So all these things together, we have this brain that's talking to the TACs over here. It's a distributed system. The pilot can see what's happening on the cockpit. If if the light comes on, that type of thing, it's just like a stuck slat. It's just a very distributed system that allows the pilot to just do his job, fly all day, and increase the efficiency of his jet and his aircraft without the structural downside of having all the metal put on the wing. Now it's my time.
Yeah, even though it's an active system, it's transparent to the pilot. It's there, it's operating, and you're just getting, most of the time you're getting all the benefits, aerodynamic benefits, because the system is dormant during a 1G flight. So you're getting all the aerodynamic benefits. Unless you need load alleviation, then it activates to alleviate that load. So that's what active winglets are about. We do have one more question and then we'll wrap up. So the question is, how has the market been for winglets during the pandemic? And do you plan to maintain the install rate of 1 per week? Is demand requiring any increase? So that's a great question. You know, the pandemic has affected life in a lot of different ways and really inconsistently. But what we've seen is people are traveling using general aviation more now. And so the airplane market, the used airplane market and the new airplane market is actually picking up a little bit. And so that's really actually helped our business. A lot of charters have started during the pandemic. We're seeing an increase in demand. And so that's really where we're seeing some of the demand. If you look at the value of adding the winglets to an existing aircraft, you get a lot more utility out of the aircraft. You can use it. The CJ2 is a great example, like Nick was saying, 800 pounds increased max zero fuel weight. Now that airplane is a plane that you can put people in and go someplace where otherwise you'd be a little bit limited on your range, especially. And the increased range. So we have CJ1s doing missions back and forth from the Midwest to the East Coast, both directions, nonstop, where otherwise they wouldn't have been able to do that without the winglets. So it's that kind of operation for the charter that we're seeing increased demand, but also people, maybe they were flying a turboprop and they're upgrading to a jet now because they're using their plane more because of the pandemic. They're flying commercial less. People want to be exposed to other people less, so they're looking at private travel more, whether they're flying or they're hiring a charter service. So that's where we're seeing some of that demand. To answer the other part of the question, what we're doing is we're expanding our footprint. We have the 3 transformation centers now in Oxford, England, in Aiken, South Carolina is the new one, and then Sandpoint, Idaho. So rather than pick up our pace here in Idaho, we're offering that in other places, which makes it more convenient for our customers and increases our total ability to install on a monthly basis. All right, no more questions. Thank you, everybody. Thank you for joining us. Please make sure and join us tomorrow. We'll be doing the NBAA sustainability panel. Nick will be participating there. And please make sure that you check out our virtual booth and reach out if you have questions. We're happy to chat with anybody.
Thank you.